In the vast chronology of our planet, there is a chapter so extreme, so brutal, and so fascinating it seems ripped from science fiction. A unique moment when the oceans, for once, were a tranquil refuge, but only because the land had become the stage for the most intense predatory nightmare life has ever known. This is the tale of the Late Permian, a lost world that paved the way for the greatest catastrophe of all time. An unusually tranquil ocean, but for a sinister reason. Our story begins 259 million years ago in the Lopingian epoch. For any marine creature, these were strangely peaceful times. The mega-ocean Panthalassa, a body of water covering 2/3 of the planet, was surprisingly lacking in terrifying giants. But this calm was a mirage, the consequence of a prior wound. Just 2 million years earlier, the Capetanian mass extinction had devastated marine ecosystems. Great sharks like Helicoprion with its fearsome spiral jaw were gone. Their relatives like Helicampodus were mere opportunists the size of a leopard shark. The last trilobites clung to existence in reduced numbers, and the once dominant sea scorpions had dwindled to a few small, insignificant species. It was an ocean in convalescence, a simplified ecosystem empty of its apex predators. And this vulnerability made it a ticking time bomb waiting for a spark. Meanwhile, all the action and the terror had moved to land. The rise of the new kings of Pangaea. On the supercontinent Pangaea, the Capetanian extinction was not an end, but a reset. It had erased the ancient rulers of the continent, the robust Dinocephalians. Nature abhors a vacuum, and at the top of the food chain, that vacuum was filled with teeth and claws by a new group of super predators, the Gorgonopsids. Imagine a creature with the mass and power of a polar bear, the agility of a big cat, and armed with a pair of 15-centimeter saber teeth, long, curved, and serrated like butcher's knives. This was Inostrancevia, the archetype of the perfect predator. It wasn't a dinosaur nor a modern reptile. It was a therapsid, a relative much closer to mammals than to lizards. Its hunting strategy is debated. Did it stalk in packs? Was it a solitary hunter that delivered a precise bite to the jugular of its prey like a prehistoric smilodon? Or did it prefer a slower, more torturous tactic, inflicting deep wounds and following its prey until blood loss brought it down? The method didn't matter. The result was almost always the same: fatal. But Inostrancevia was not alone. It was just the largest of an extensive and terrifying family. While it patrolled the cold, arid plains of what is now Russia, in the lush, warm ecosystems of southern Pangaea, South Africa, and Tanzania, another branch of Gorgonopsids, the rubigenes, had evolved independently. Here, Rubigia atrox was the reigning terror. Although slightly smaller than its northern cousin, it made up for it with a grotesquely large and thick skull, reinforced with bony knobs and crests, a clear adaptation for fighting and subduing huge resistant prey. Its bite was surprisingly weak for its size, comparable to a wolf's, but it didn't need power. Its fangs were not for biting, but for slicing. They were natural daggers designed to sever muscle and arteries with a slashing motion, and the nightmare multiplied. Fossils suggest Inostrancevia even migrated south, entering Rubigia's territory. Imagine the encounter between these two titans, two different evolutionary designs for the same trade: death. The scars on the fossilized skulls of these animals tell a story of violent confrontations for dominance. A cast of secondary monsters, as terrifying as the leads. The Gorgonopside dominion was overwhelming, but not absolute. Other predators found their own niches in this brutal world. The Therocephalians, close relatives of the Gorgonopsids, were more diverse and, in many cases, stranger. Some, like Moscarinus, mimicked the design of their larger cousins, hunting like jaguars with disproportionately large heads. But others explored unique and sinister evolutionary paths. Take Ichibengops and Eucymbersia. Analysis of their skulls reveals grooves and cavities next to the fangs that, for many paleontologists, are the first evidence of venom in a terrestrial vertebrate. Imagine being taken down by a predator the size of a wolf, only for its bite to inject a paralyzing or deadly toxin. And then there was Megawaitsia, a giant Therocephalian that rivaled Inostrancevia in size. It is believed it might have used its possible venom to hunt the largest herbivores of the time. But danger didn't only lurk on solid ground. Freshwater waterways were ruled by giant predatory amphibians, the temnospondyls. Creatures like Uranosentrodon in Africa, 4 meters long, combined the body of a giant salamander with the head and instincts of a crocodile. They were the absolute masters of rivers and swamps, ambushing any animal that came to drink. The survivors, herbivores in a besieged fortress. In this nightmare world, being an herbivore required extreme specialization. Evolution responded with ingenious designs for survival. The Lystrosaurus, a pig-sized animal with a pair of blunt tusks, became the master excavator of Pangaea. Its robust forelegs allowed it to dig complex burrows to hide from the legion of predators. Others, like the cistocephalids, took the subterranean life to the extreme, with incredibly flat, strong skulls that acted as rams to tunnel underground. For those who couldn't hide, the option was armor. Scutosaurus was a pariasaur the size of a rhinoceros, a living tank covered in thick bony plates and knobs that made it nearly invulnerable. A blow from its powerful legs or the weight of its body could deter even the hungriest Gorgonopsid. The end of everything. The great dying. This world of titans, this brutal and fascinating balance, was living its final days. 252 million years ago, hell on Earth became literal. In what is now Siberia, the planet's crust tore apart in a cataclysmic event known as the Siberian Traps. It wasn't a simple volcanic eruption. It was a rain of fire and sulfur on a continental scale. Lava flows 1.5 kilometers thick covered millions of square kilometers. But the fire was only the beginning. The volcanoes released unimaginable quantities of carbon dioxide and methane, triggering a runaway greenhouse effect. Global temperatures soared to 35 degrees Celsius, 95 degrees or more. Sulfur gases poisoned the atmosphere and destroyed the ozone layer, bathing the surface in lethal levels of ultraviolet radiation. The oceans absorbed the CO2, becoming acidic and oxygen-deprived, suffocating the already weakened marine life. On land, ecosystems collapsed in a chain reaction. Plants died, herbivores were left without food, and the magnificent predators, the Gorgonopsids, the Therocephalians, the giant amphibians, watched their entire world crumble before them. They could not adapt to change so rapid and brutal. It was the Great Dying, the most severe extinction event in Earth's history. 96% of all marine species and 70% of terrestrial vertebrates disappeared forever. The reign of the saber-toothed predators ended not by a better rival, but by the planet itself turning against them. A world rebooted. The Late Permian shows us an alternate world, a Gorgonopsid Earth that might have been. Its abrupt end cleaned the slate completely, but from the ashes of this catastrophe, new protagonists would slowly emerge. First, the surviving mammal-like reptiles, and then the dinosaurs, who would inherit an empty world and shape it in their image. It is a humble reminder that no dominion is eternal, that even the most perfectly adapted creatures, the most terrifying predators, are at the mercy of the gigantic mechanisms of our planet. The story of the Permian is a lesson in fragility, resilience, and the overwhelming power of Earth to give life and to take it away. What did you think of this journey to the Permian? Which of these creatures do you find most fascinating or terrifying? Let me know in the comments, subscribe so you don't miss our next trip through time, and hit the bell. See you next time.